Let's take a look at number 18. It says initial deposit of $4,000 is made in a savings account for which interest is compounded continuously. Balance will triple in 15 years. What is the annual rate of interest for this account? Okay, so it says compounded continuously, so that's my PERT formula. That's A is equal to P e to the RT. If it uses the word continuous, then use this formula. If it doesn't say the word continuous, then you'd use our other interest formula. A equals P times 1 plus R over N to the NT power. So let's see what they give us. Initial deposit of $4,000, so they're telling us P is $4,000. Is made in a savings account for which interest is compounded continuously. Balance will triple in 15 years. So they're telling us T is 15. What is the annual rate of interest for this account? So they're wondering what R is. Okay, so let's plug in what they give us. Okay, so we got 4,000 for P. E, R we don't know, but T we do. It's 15, so this becomes 15R. Now A we don't know, but it says the balance will triple. Well, if it starts out with 4,000, triple that is 12,000. Excuse me. And this is now an exponential equation. We want to solve it for R. Let's refresh our memory on the steps. So exponential equations. Step 1. Get the part with the variable in the exponent by itself. Step 2, take natural log of both sides, ln of both sides. Step 3, use properties of logs to get the variable out of the exponent. And step 4, solve for x, or whatever variable you have. So let's use these steps to solve this problem. Okay. Step 1. Get the part of the variable in the exponent by itself. Well, the part of the variable in the exponent is the e to the 15r. Well, if I divide both sides by 4,000, that'll do our first step. There we go. Well, when I do that, those 4,000 is going to cancel. 12,000 divided by 4,000 gives us 3. Equals e to the 15r. Step 2, take natural log of both sides. Take ln of both sides. So we got ln of 3 is equal to ln of e to the 15r. Step 3, use properties of logs to get a variable out of the exponent. We have a property that says if you have a log out in front and you have a power, you can take the power and put it out in front. We could have also used another property. It says if you got natural log of e, that cancels away and leaves you the exponent. Because down here, natural log of e, those can cross off because it's just equal to 1. And we end up with 15r. So there's a couple different ways you could have done step 3. Now step 4 is solve for r. So we'll divide both sides by 15. And then we'll plug this in our calculator. Now what you do is you push your ln button. You do 3, and then you put a closing parentheses. Now this is in the old TI-84. If you got one of the newer TI-84s, you probably push your natural log, and if I had to guess, you do a 3 and do a right arrow, but maybe not. Divided by 15. You can kind of tell just by seeing what our answer is. You can figure out how to plug it in. I'm lying. I got one of the new calculators here, and I pushed ln, just puts beginning parentheses. So 3, closing parentheses. Oops. Did it wrong. ln 3, closing parentheses, divided by 15. Oh, an enter. I forgot to put that. Now, if you're in graph mode, make sure you do a second mode X out before you get here. And we get R is equal to 0.0732. Now this is decimal. Usually rate is in percent form, so we'll move the decimal place 2 places to the right, and we got 7.32%. 7.3. Okay, they round 1 decimal place, but it'd be B as in Bill. So let's go check. 18B. And that checks.